Hi, I'm Larry Johnson. I'm a professor at Texas A&M University, and today we're going to talk about the digestive system.
Digestive system, the Pyloroduodenal junctions, the crypts of Liberkuhn, intestinal glands, the cells, absorptive, mucus, pannate cells, endocrine cells, small and large intestinal features, submucosal, Bruners glands, central lacteal, and nerves.
So if you come from the pyloric region to the duodenum, you go from gastric pits to all of a sudden you have intestinal villi. So we're coming out from the pyloric region to the small intestine. Now you pick up villi, you pick up goblet cells, you pick up brush border of the absorptive cells as you get through there. And we can see that junction. This is a pyloric duodenal junction. This is the stomach down in here. And then that would be the pyloric region, of course. And then these are the villi of the intestine. So right about here is where you have the junction to occur. Lamina propria, muscularis mucosa, and also you would have a big sphincter there. It's probably a sphincter that's associated with opening and closing the stomach. So here we have the stomach, the gastric pits, the gastric glands, muscularis mucosa. That's the intestine here, intestinal villi. You got goblet cells, you got brush border, uniform macrovilli in these cells, as you can see. And so right in through there is where you have the junction to occur. This is the stomach, and then this is the intestines. In the duodenum, you have these glands. These are Bruners glands, and they empty into the crypts of Liberkuhn. So they'd empty in here and finally discharge up to there. So in the small intestines, you have intestinal villi projecting them through there. Sometimes the submucosa is enfolded in. And then, but in the large intestines, you do not have intestinal villi. So at the bottom of these glands, right in through there, you have special cells. These are the pannate cells. And these cells, so when bacteria is coming in, they have lysosome that can kill the bacteria. And so here we see in the duodenum, you have the submucosal glands, and we call these Brunner's glands. These are Brunner's glands, and what they do is they help reduce, they raise the pH of the ingesta as it's coming in through there from the stomach, is what they do. And here we can see intestinal absorptive cells. You have a brush border on the surface. This is the crypts of Liberkuhn, or the glands that we see, and also we have goblet cells that we see there. So in the intestines, you have intestinal villi, you have microvilli, which makes the brush border, and you have goblet cells. And we can see at the bottom of these, we have another cell, the pannate cells, and as the bacteria slide down the crypt of Liberkuhn, they all of a sudden encounter these granules of this cell to be discharged into the lumen, and that would be the pannate cells to be discharging. Also, we have goblet cells and a brush border of the intestinal absorptive cells, simple columnar epithelium. Another cell that's there is the endocrine cell, or argentifin cell, and you can see its granules at the base. And so if you use a PAS staining for the intestine, you can see the brush border is PAS positive. Also, you can see the goblet cells. So these are the goblet cells that have the mucus type that's carbohydrate rich. You can also see the basement membrane of these intestinal absorptive cells right here. So this is the base, and then there is the apex. We can see macrophages in here. Macrophage is a nucleus, another nucleus of a macrophage, and you see different sizes of granules and different densities of those granules, characteristics of macrophages. Also, there's a lymphatic in here. This is a central lacteal. And so fats coming here, resynthesized in this kind of green area through here, which is a smooth endoplasmic reticulum, goes out through the chylomicrons and is discharged into the central lacteal to find its way to the thoracic duct and back into the blood and into the bloodstream. If we look at the lamina propria, behold, we see some macrophages in here, but here we can see there's a macrophage, there's a lymphocyte, this is a plasma cell, smooth muscle cell, and these are intestinal absorptive cells at the very bottom, and you can see a basal lamina going around these cells. So if you look at the apex of these cells, you can see the brush border, which is a uniform macrovilli. You can see the terminal web in through here, which anchors those villi. You can see junctions between adjacent cells. There's one junction there. And you note that the goblet cell has the secretions inside there. These are goblet cells here. But the goblet cell doesn't have a brush border. Their job is not absorption, as are the intestinal absorptive cells. And then here we see the chylomicrons. So the fats are resynthesized here, go to the lateral borders, and the chylomicrons is in the lateral borders between adjacent cells. It goes down to the lamina propria and gets into the central lacteal. And so here we can see the mitochondria, lots of mitochondria, and through here the chylomicrons as they make their way to the lamina propria. If you look at the apex again, we can see the brush border. You can see that the actin filaments come down into the terminal webs. Lots of mitochondria associated with transport that's needed there. You can see the brush border with H&E and also with toluidine in blue. And you can see the terminal bars between adjacent cells, which would be the junctions. The zonia occludens, zonia adherens, and the desmosomes make up the terminal web, the terminal bars. So if you, this EM is cut right through just above the nucleus. So we see mitochondria, there's a nucleus here and there's a nucleus there, and they have a rich Golgi apparatus. So this is Golgi here, 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 and a lot of vesicles associated pitching off from there. This is one cell and another cell, and you can see the plasma membrane between adjacent cells is folded up so it can open up if it needs to. Rough in the plasma reticulum, smooth in the plasma reticulum, budding rough ER, and also we can see some budding rough ER here, coated vesicles for transport to occur. If we look at a piece of the gut, and we can see here, this is the muscularis externa, and it's controlled by the Mystras, by the Mystras Plexus, and you can see these are nerve cell bodies. This is a nucleus cell body, will be out here and out there, nucleus and the nucleolus. Well, also in the submucosa, you see the Mystras Plexus. This is a Mystras Plexus. This regulates the muscularis mucosa that we see radiated through there. So the nerves, in this case, control the muscularis externa. This one in the submucosa controls the muscularis mucosa. So smooth muscle contraction is controlled by the nervous system. If we look at that with H&E, we can also see this is the nucleus of a cell body, and then we have a cell body here. These other guys here are satellite cells. This is the Mystras Plexus located between the circular and longitudinal muscle and the muscularis externa. So we're really on this layer right in through there. So this is smooth muscle in either case. Here we see the pennant cells at the bottom that we see there. Also in the submucosa is the Mystras Plexus, and you can see the ganglion cells again are the Mystras Plexus that regulates the muscularis mucosa that we see right there. So the muscularis mucosa, lamina propria epithelium, that makes the mucosa, and we see intestinalvilli in the small intestines. So we can see the pennant cells, as we mentioned. Also located there are a host of these endocrine cells, as you can see, with the granules at the base for discharge in the lamina propria. Now, if you look at the large intestine versus the small intestine villi, the large intestine has these glands, and these has glands too, but you cut these off, and that's what you see there. So if you remember in the beginning, only the small intestines have intestinal villi. The large intestine does not have intestinal of villi. As we see, they just have these crypts of Liberkuhn.
We want to acknowledge the original source of diagrams and figures that may have been taken from textbooks, and we acknowledge that here. This is the end of the digestive system, Pyloroduodenal junction, crypts of Liberkuhn, intestinal glands, cells, small and large intestinal features, submucosal Bruners glands, central lacteal, and nerves.